Hi, this is Chrisferb, and I'm going to be reviewing an example of a confidence interval using a t-distribution. Okay, we'll get started. Okay, so here's the sample problem. It says, construct a 95% confidence interval for a sample mean of 18.4, sample standard deviation of 4.2, and a sample size of 13. I pointed out in the way I made this, I reiterated the sample mean, that it's a mean that is of a sample standard deviation, so it's a standard deviation that comes from a sample, and of course the sample size is usually always the same. So when we take a look at this, we will go and be forced to use the t-distribution, and this is why. We have an unknown population standard deviation. We do have a sample standard deviation, which is our big S, and the sample standard deviation is 4.2. We also have a small sample size. Our sample size is 13. Our sample mean is 18.4. So we have an unknown population standard deviation, and we have a small sample size, which is n is less than or equal to, it's actually less than 30. And if it's less than 30, then we are going to use the t-distribution. Okay. Make sure I'm on the camera here. Okay. We're going to use the t-distribution, and that's because small sample, unknown population standard deviation. Okay, our formula for this is very similar to the z-distribution calculation, except we're using the t, so it's just a little bit different. Whenever we use the t, we get a little bit more of a variation. And that's because the t-distribution is an estimation of the z, essentially. Has more variation. Big S over the root of n. That is our formula we'll use. And then the first thing that I do is I start calculating the pieces. I'll calculate this piece. We'll figure out what our t is, and then we already know what our x bar is. So our t, let's do that first. So for our t, we have to go to the table, and we're going to use our degrees of freedom. So our df is always equal to, in this case, n minus 1. And so our n is 13. So our df is going to be 12. So we have 12 and then 95%, which you could write out as 0.95. A confidence interval. Okay, let's take a look at the t-distribution table. In our t-distribution table, I'll zoom in just a little bit. So our t-distribution table, whenever you're looking at the t-distribution table, in this case, this is a table that's set up displaying the significance levels of alpha, which is something that we're interested in when we do hypothesis testing. Essentially, with confidence intervals, we're looking for the kind of the beta value, which is the value that's on the inside of the distribution. So when we take a look at this thing, if we're looking for a 95% critical essentially value that we're looking for, or a level for this, when we're looking for 95%, we want to find the two-tail 5% on this table, because we need that inside part, which is 95%. I know that might sound confusing, but this table is set up, and I believe most of these t-tables are set up in the same way as this table. It's set up like you're doing a hypothesis test, which has the one-tail, two-tail, and it has 5%, 10%. So they're really small numbers. These are all tail values, and we want that middle part. So let's go back and I'll show you here. So our degrees of freedom was 12. So we go 12, and then we go over, and we go over to the two-tail 5%. So the two-tail 5% is 2.179. And that's, like I said, it shows up on this table as 5% two-tail, but that leaves us with 95% for the beta, which is the inside part. This is kind of set up heavily weighted towards the alpha side. Okay. So that was, I'm going to back this off a little bit. That's better. Okay, so that was the value that we got off the table was 2.179. So okay, real quick, what I was talking about, if we have a distribution that's like this, the table, when it's talking about 5%, say 5% two-tail with a T, what it does is it has, in theory, it's saying 2.5%, 2.5%, and the rest of it's all in the middle. But when you look at the table, it says, 10% one-tail or two-tail, 5% one-tail, two-tail. But we're actually looking for a 95% confidence interval, so we just look for the inverse of what we're looking for. So when we go and we find the 5% two-tail, it actually leaves us with 95% in the middle. That's the confidence interval, which is this middle area that we're going to figure out where this upper and lower range is. That's kind of how that works. Okay, moving on. We have our T value, which is what we needed. And now all that we're going to do is we are going to work out this part right here. So our S is our big S, standard deviation, which is, make sure I'm on the screen, I'm going to scoot up. 4.2 over N. Don't confuse this with the degrees of freedom, which is one less, but our actual N is 13. And where I already have this calculated out, so our answer is 1.1648. Okay, that's a 4 right there. 1.1648. Okay. Okay, so that's what that part is. I'm gonna back this out just a little bit more. Okay. Okay, now we can put it all together. So our X bar is our 18.4. We'll do minus on that one. Then 18.4. We'll do plus on that one. And the first part, which is our T was 2.179. Same for both, 2.179. And then this is our, we put in our value right that we calculate right there. So we're going to put in 1.1648. If in doubt, go out 4 decimal places. I don't recommend rounding, just the way I do it. 1.1648. And if we bring both these down because I'm out of space, the negative, the low side of this range, of this confidence interval, ends up being 15.8619 up to the high range of 20.9380. Make sure I'm on the screen. Okay. Okay, so now let's take a look at the calculator. On the calculator, we use the stat. So I'll write it over here. So I'll write it up here where nothing's covered up. We use stat T interval. Very similar to the Z if you've already seen that video. Okay. And we're just going to put the data in. Okay, so I have the calculator up, and I'm going to go to Stat. Then I'm going to go over 2 on the right side, 1, 2, and then go down to T interval, 1, 2, 3, 4, 5, 6, 7, 8, or it's down to 8. Okay, T interval, I hit Enter. And now it's set on stats. On the prior video, I started with data, and then I got to the list editor part, and it's like, oh, that's the wrong one. So you do stats. We're not using a list of data, although you could if you did data. So now we go down. Okay, so our X bar is 18.4, and our SX, which is our sample standard deviation. Whenever you see it in the calculator, SX, the big S, X is sample standard deviation. We do 4.2. And then our N is 13. Down. And our confidence level is already set up as 95. So I'm going to go down, and then I'm going to hit calculate. And let's see if our answers are very similar. 15.86, 15.86, and then 20.93, 20.93, 8. So we're doing good. Thank you for watching.